Hello everyone, welcome to online classes. So in this video we are discussing about Eamcet Maths. The topic is integrations. So in this video we are trying to cover as many problems as possible with logic. So first problem is he gave u equals to x cube plus y cube by x minus y, and he stated that x du by dx plus y du by dy equals to k into e. So then find the value of k. So what he has to find the value of k. So we know that we have to in order to find the value of k, we have to substitute at the place of x. We have to write k into x, and at the place of y we have to write k into y. So as you substitute, it will becomes messy. See, the concept here is you have to subtract the numerator power with the denominator power, as the numerator has same power x power 3 and y power 3, and denominator has also same power x power 1 y power 1. So you can simply subtract to get the value of k. 3 minus 2 equals to 3 minus 1 equals to 2. So this is the value of k. So it's you need not to take any simplifications and so on. So in this problem he has to find the solution for this integration. So as we do conventional method, it will becomes t. We have to write t equals to the term whatever it is in the brackets, we have to consider as a t or x. So it will becomes log x, and as we differentiate this term, dt becomes differentiation of 1 is 0. So log x differentiation becomes 1 by x into dx. As we substitute in this equation, it will becomes integration 1 by t cube into dt. So as we simplify this one, we will get t power minus 2 by minus 2. So that will becomes 1 by minus 2, 1 plus log x whole cube. So this is a very lengthy problem in the exam point of view, Eamcet point of view. See the problem. He gave log x in the brackets. The differentiation of log x is 1 by x, as you know that, and here the power is 3. So directly you write as using the formula. In considering this formula, you can directly plug in the values of t. T becomes this total bracket term, and n becomes 3. So if we write, it will becomes 1 plus log x minus 3 plus 1 by minus 3 plus 1. It will give the value of same. So in this problem he asked to find the degree and order of the differential equations. So as we know that order tells the type differentiation, and the degree tells the power of that differentiation. So highest derivative we have to find in this equation, which is in highest derivative. So you see the first term dy by dx has only first, it's a first order differentiation. It's become first order, and this term d square by dx square, d square y by dx square is second derivative differential equation. So this is y power 4, a constant term, a variable term. So in these three terms, the order is highest differentiation is 2. So that means order is 2, and the highest differentiation degree becomes highest differentiation power becomes degree of that differential equations. So the power for this second order differentiation is 3, so that becomes degree becomes 3. So in this problem he has to find to solve this differential equation. So we can write we can take a variable separable method here. So that becomes dy by dx equals to 1 plus y square by y equals to x, and I am writing 2 as here. If we rearrange this equation, it will becomes 2y by 1 plus y square into dy equals to dx by x. As we integrate this term, this dx by x becomes log x, plus as a constant we have to write as log c, and the right hand term becomes as we consider this as t, y square, the power is here 2. The exact same term will be appeared at the numerator side, so we can simply write this whole term as log 1 plus y square. So whenever the power is in multiple available at the numerator part as a multiplicative term, we can write as log 1 plus y square. So as we simplify this one, log a plus log b becomes log a plus b, log a into b, x into c equals to this term. So log gets cancelled, the solution becomes 1 plus y square equals to x into c. In this problem he has to find the solution for this equation. We can do conventional method as dx by 1 plus e power minus x means 1 by e power x. So as we simplify this term, it will becomes e power x plus 1 by e power x into dx. So if we assume denominator as t, e power x plus 1, as we differentiate dt equals to e power x dx. If we substitute these two values, we will get integration 1 by t into dt. So overall solution becomes 1 by t becomes log 1 plus e power x. But this is the lengthy problem for the exam perspective. See, whenever negative term, single negative term, negative power terms comes in the denominator, surely answer will be in the form of log. Surely answer in the form of log. Why? Because as we assume denominator as t, there is no such term available at numerator to assume as dt. So that means only log term will be applicable. As we know that if we assume this as t, so that term will appear quite differently. So here we got negative term e power minus x, answer will be e power plus term plus c. So both the answers will be same. By doing little bit of practice, you will came to the answer with a short span of time. So the solution for this problem as with the conventional method is, so we can write the power as into the front side, 2 log x by x into dx. As we consider t as log x, we get differentiation as 1 by x, and the term becomes 2 t into dt. So that becomes 2 into t square by 2 plus c. So that will give the answer of log x whole square plus c. So this is some lengthy problem. The short trick is here is ultimately we have to shift the power into the front side. in order to do the calculation, whenever log term is came across to the numerator, we can directly write it as in terms of square. Why? Because we have only at the numerator only we have log x. There is no such other term available here, so we can directly write as some square, and that term which is in the brackets will depends upon the differentiations. We have to consider the log x. The differentiation of log x becomes 1 by x, so we can simply directly write as log x whole square plus c. So in this problem we can directly write the answer as, so tan inverse x to the power whole square by 2. So direct answer how it's come means, so if we consider normally we have to consider we in the process of integration by substitution, as a t we have to consider as t only numerators with the proper identification, and denominators which are in brackets, and the terms which are in brackets, and the terms which are in under the roots. So we have to consider those terms as t. Especially we have to give the focus for these two things. So as if we consider as numerator part as t, the term must be dx term must be rely in this same equation, same problem. So the tan inverse x differentiation becomes 1 by 1 plus x square, so that we can write directly as tan inverse x by 2 by 2. It becomes integration of x. It becomes as a integration of x, so the formula will be x square by 2. Same concept will be applied here. The next problem is, so we have to simplify this equation. So if we substitute t as a denominator, we will maybe or may not be, we will get numerator term. So it's a lengthy process. So we know the formula that integration 0 to a f of x equals to f of x dx equals to integration 0 to a f of a minus x into dx. So if we apply this formula here, we will get this problem comes under into I problem. So we have to consider as I. So then it becomes 0 to pi by 2. Sin pi by 2 means cos pi by 2. So if we substitute sin in the place of x, if we substitute pi by 2 minus x, it becomes cos x, and cos x becomes sin x, and the denominator part shifts also, cos x plus sin x. Why? Because cos pi by 2 minus x equals to sin x, and sin pi by 2 minus x equals to cos x. So here we got two terms, I plus I, two terms. It is also I, this term is also I. So if we add these two terms, it will becomes integration 0 to pi by 2. Numerator part will be sin x plus cos x. We get the terms which are in the numerator will tends to cancel, gives a value of 0. So that means I equals to 0. No need to do the calculation. By simple understanding, we will conclude that answer is 0.